All right, good morning. Um, so you guys are probably trying to figure out like why Mrs. Haugen, why are you having us do this like kind of old school paper pencil way? We are going to be solving what's called a system. I'm going to describe what that is here in a second, by graphing. And basically, we need to have our graphs be very, very accurate as we're doing this. Um, so because of that, we need to do it paper pencil because the iPad's great, but we're not as exact with our graphs when we're graphing it on the iPad. So that's the reason why we're doing it paper pencil, because we're going to be able to be very, very exact with it. Using our pencils, because it's a much smaller kind of point than our iPad would create. And also we can get a much straighter line using our rulers versus doing it on the iPad. So again, super old school for you guys, but that's kind of the reason for it. And homework will be the same way as well. So what is a system of equations? And actually I should be more specific and say systems of linear equations, because we're only going to be working with our linear equations that we've been doing all year. Basically it's a system, which means it has multiple parts to it. So if you think about like a system and how things work, there's usually multiple parts to it. So same thing with our system of linear equations. It's going to consist of two or more linear equations. And when they're put together, they form a system. It's kind of like in Unit 7, I think it was, or Unit 6, one of the two, when we talked about compound inequalities. We were putting two inequalities together. Systems of equations is similar. We're putting two or more equations together that both have to meet the same criteria. Okay? I'm being specific in saying linear equations because you could have a system of quadratics, of cubics, and so on and so forth. You'll learn about those later. In 8th grade, up through basically the beginning of May, we only focus on linear equations. Okay? We are also only going to focus on the systems who only have two equations, like you see here. They could have lots more. In the real world, in chemistry and in physics, your systems realistically in the real world are going to have more equations in them. Okay? But for our purposes, we're only going to have two. Okay? So this is an example of a system, and I should be more specific. Our systems usually are shown with these kind of like brackets with them to show that they're together. Sometimes in the lesson, based on where I copied and pasted stuff from, they'll have these. Sometimes they won't. Okay? But just so you know, if you see two equations together, it's a system. And so we're going to be graphing or solving both of them at the same time. Okay? Now, when we solve this, basically what we're trying to do is we are trying to find an ordered pair, so an x and a y, that works in both equations at the exact same time. We can only have a solution if it works in both equations. It's kind of like this. If you were to go, pretend that you have two adults at home, and you have to get permission from both of them in order to go out on Friday night. Okay? This is mom. Mom says yes, but dad says no. You don't get to go because you have to have a yes from both of them. So for it to be a solution, both of them have to be a yes. The ordered pair has to work in both of them. We're going to use that idea to check our solutions today to make sure that when we're graphing, we end up with the correct answer. Now, there are different types of solutions that we could get. Most of the time, you're going to get exactly one solution. That happens when the lines have different slopes and they have different y-intercepts. You'll notice on this graph here, you'll notice that it has exactly one solution because it intersects at one point. Well, right there. I have a pretty big highlighter there, but that's okay. So they intersect at one point. That's our solution. And we would list that ordered pair. We can also have something called an identity or infinite number of solutions. This means that it's the exact same line. The equations look exactly the same. They have the same slope and they have the same y-intercept. And when you graph, the two lines are right on top of each other. They're the exact same line. So that means no matter what ordered pair we were to pick, it would always work. Then we have a situation where we have a no solution or it's considered to be undefined. You're just going to tell me that's a no solution. This is when the lines are parallel to each other, meaning they have the exact same slope, but their y-intercept is different. You'll notice from the graph that these two lines are parallel. They are the same distance apart the entire time as you move through the graph. So this is an example of a no solution. So as we go through and do our examples, we're going to take a look as far as how many solutions will the system have. We're going to be graphing all of our solutions. And if it's one of those cases where it has exactly one solution, we're actually going to name that ordered pair. So here are steps that we're going to use to solve our systems by graphing. Technically, I'll tell you guys there are 3 ways to solve a system. You can solve a system by graphing, by substitution, and elimination. I will be honest, kids use graphing and elimination. So in this unit, those are the 2 methods that I'm going to teach you. Most kids hate substitution. They're probably going to teach it to you at the high school at some point, but for our purposes, we're only going to focus on this unit using graphs and elimination. Okay? So here's our steps on how we graph. First thing is we always want to make sure the equation's in slope-intercept form. Remember that's y equals mx plus b. Remember slope-intercept form, really what that means, if you have to change it, you're solving for y. So if it's not in that form, you just need to solve for y. Remember, we did this, it's been a while. When we did this when we were graphing, remember b is where we begin. And remember we always begin on the y-axis unless it's an example of a vux. Remember vux is our vertical lines and it starts on an x. The m, that's our slope. This is going to be how we move. And remember that is our rise over run. Maybe I'll write that here too. And think about slope, dude. Whether it's puff, puff, positive, nice, negative, zero, fun, or undefined. We'll bring some of those things back. So first thing is going to be making sure it's in this form. Most of the examples that we see today are going to be in this form because I'm setting you up to basically say like this is when we would use graphing. If they're not solved for y, chances are you're going to use elimination. All right, after we do that, we're going to graph both equations on the exact same coordinate plane. We're going to use a ruler and some other straight edge. So let's say you don't finish the homework assignment in class today or in prime time, and you get home tonight, just use like an edge of another sheet of paper. Use an index card, the edge of a Kleenex box, something that has a straight edge so you can get a nice straight line and make sure your line is exact then. Then we're just going to locate the point of intersection, and you're going to tell me that as an ordered pair. Remember, ordered pairs are always written as x comma y. Then it's always a good thing because you can always check your solutions for these. I'm not going to require that you do this step, but we are going to practice it today, that you can check the coordinates, the ordered pair, by plugging them into both equations. As long as it works in both equations, it's automatically a solution. And that's what I have bolded down here. Again, that intersection point must work in both of them in order for it to be a solution. All right, let's take a look at our first example. So we want to graph both of these. First thing is we want to look, are they both solved for y? So I see y equals. Step 1 is done. We're able to go ahead and graph. Now, it's your choice. If you want to tell me right away how many solutions it has, you can do that. Most students won't do that until after they've graphed, and then they can look how many solutions it's going to have. So I'm going to graph this first one in blue. You can always choose to use different colors or just use your pencil. I'm just going to use different colors to make it easier for the lines that I'm referencing. So starting with example A, This one's y equals negative 3. You'll notice on this one it's solved for y, but there's only one letter. Hopefully you remember this is an example of our hoy. If there is only one letter, it's a hoy or a vox. Because this is a hoy, we're still going to start on the y-axis. So I'm going to start at negative 3. And H stands for horizontal, so I'm going to draw a horizontal line going through that. Now you guys have a ruler. You guys are going to be using a ruler to make your straight edges. Unfortunately, in the iPad, I don't have that. So your graphs are going to look much nicer than what I'm doing. Okay? All right, now I'm going to graph this next line on the exact same coordinate plane. This one has 2 letters, so this graph is going to be a diagonal. So I'm going to think about my b value, which is that number without the letter. That's where we begin. And the number in front of x is our slope, or my m. But remember, our slope has to be a fraction. So if it's not a fraction, put it over 1. So let's graph. I'm beginning at negative 3. Again, always on the y-axis, unless it's an x equals equation. And we actually won't see any of those today for our practice. Then I'm going to move going up 1 over 1. And remember, when we go over, it's like how we would write a sentence. We're going over to the right. So up 1 over 1. I encourage you guys to do multiple points. The more points you can put on your graph, your line will actually be straighter. So once you have a couple points, just doing rise over run again, go ahead and use your ruler and make a nice straight line. And again, yours is going to look way nicer than what mine does, but I know how the graphs are supposed to look, so I'll still make it work. Once you graphed them, that's steps 1 and 2. Now we're going to look for that solution. We're going to look to see where does it cross the x-axis. Not the x-axis, I'm sorry, where do the 2 lines intersect? I was changing the color of something. And the 2 lines intersect right here. So we're going to name that ordered pair. So that ordered pair is 0, negative 3. And since our lines intersect, this means there is exactly one solution. So basically you're graphing the 2 lines, telling me where they intersect, if they do, and that it has one solution. If they don't intersect, no solution or infinite solutions. I did talk about that we can check our answers. Let me show you how you would check. So you're going to check the ordered pair that you just found the intersection point of. And you're going to plug it into both equations. So I'm going to start out with y equals negative 3. The y value for my ordered pair is negative 3. So I'm plugging that in for this y value and writing the rest of it equals negative 3. Sweet. Those 2 are equal to each other. It's the solution in the first equation. Mom said yes. Now I'm going to check in the second solution or second equation. There's my original. And where I see the x's and y's, I'm going to put in the corresponding number. Y is negative 3 in my ordered pair. X is 0. And then we can use our calculators to check. 1 times 0 minus 3 is negative 3. So again, these 2 sides equal to each other. So our other adult at home that we need permission from also said yes. So this for sure is the solution. So that's how you can check to see if your answer is correct. If you guys have questions, see if you can help each other out. Otherwise, let's take a look at our next example. All right, in example B, let's first check to make sure both equations are solved for y. And we know they are if we say y equals sweet, y equals sweet. They're both solved for y. We're ready to graph. I'm going to graph the first one in blue. My b value is that number without the letter, so that's -6. And my slope is 1. And again, it's not a fraction, putting it over 1. Let's graph this first one. So starting out at -6, and remember, always start out at the y-axis, unless it's a vux. And then when you do your slope, you move from that point that you just put on the graph. So from this point, I'm going to go up 1 over 1. And again, I put in a couple points and then use my ruler to make my graph as straight as possible then. So it should look like something like this. Now let's graph our next one. I'm going to do this one in red. My b value is 2. My slope is 1 over 1. So this time I'm going to start out at a +2. And I'm going to go up 1 over 1. And again, my points aren't super nice because of using the iPad. It's just what it is. And I can't enlarge either, like you guys are able to. Once you have your slope, use your ruler to make a nice straight line. Now take a look at our graph. Did the lines intersect at all? Nope. So this means this is either an infinite solution or no solution. Do we have two separate lines, or are the lines right on top of each other? Hopefully you're thinking you can definitely see there's two separate lines. If there are two separate lines and those lines do not intersect, this is a no solution. So that means there's nothing for us to check at all, because no matter what ordered pair we pick, we could go years and picking random ordered pairs and nothing would ever work in both of them. Kind of think about it this way. There's nothing you could ever do to get your parents or your adults at home who are in charge of you to ever get you to say that you could do something. Let me use an example. Maybe you say you want to move to California. That might be an example of where both the adults at your home are going to say no every single time. No matter how much you please them, they're always going to say no. No solution. It will never, ever happen. Okay? All right, let's take a look at this example. So on this one, you'll notice these equations are no longer solved for y. They're actually set up kind of nice to do what's called elimination, which we'll learn about tomorrow. But I'm going to force you guys on this one, in case you hate elimination, how you would do this one with graphing. So I'm going to start with this first equation, and we need to solve that for y. So I'm going to rewrite it and think about what do we need to do to get y by itself. So I'm going to do keep, change first and add my ones in front of my letters. And you guys got really good in this with this. Again, unit 6-ish, I think, where we're solving for y. So you're going to circle the y and the number in front of it, minusing 1x from each side to get y by itself. So we're left with negative 1y equals negative 1x plus negative 2. We can't stop here because there's still a negative in front of that y. So we're going to divide absolutely everything by negative 1. So that first one ends up being y equals negative 1 divided by negative 1 is a positive 1x plus negative 2 divided by negative 1 is a positive 2. So here's our first equation, solved for y. I'm going to go ahead and graph it right away. So we're going to start out at a positive 2. And our slope is 1, up 1 over 1. You're going to find a lot of times your slopes are going to be 1 or 2. They're going to be pretty small, so that way they can fit on a graph. But they won't always be as we go through some of our examples, and as you guys get to the homework assignment. And then let's go ahead and solve this next one for y. Again, I'm going to put a 1 in front of each of my letters. You wouldn't have to. Some of you guys are comfortable doing it without that, and that's fine. Trying to get y by itself. Adding 1x to each side. So 1y equals 1x plus 2. Dividing everything by 1. So y equals 1x plus 2. Now, some of you guys might be already noticing something about the equations. If not, we're going to graph and see what you notice. I'm going to start out at positive 2. And then we're going to go up 1 over 1. And you might be thinking, Mrs. Haugen, these two graphs are identical to each other. You are exactly right, because the two equations are exactly the same. So as soon as the two equations are exactly the same, the graphs are going to be the same. So this one has infinite solutions. So that would be our answer for this one. Now, just so you know, technically, it's considered to be infinite solutions. If you guys want to make a shortcut, you can always use that all real numbers. Just remember, infinite solutions and all real numbers are pretty much the same thing. Okay? If you guys have questions, help each other out on that one. And then let's take a look at our next example. All right, example D. First thing, let's make sure they're both solved for y. Y equals y equals. Awesome. We're ready to solve or ready to graph. So in this first one, I'll be honest, just because of what I wanted you guys to see in the graph, your b value is 11, so we're going to be off the graph just slightly for this first point, but that's okay. My slope for this one is negative 3. Remember, if it's not a fraction, we're going to go over 1. So I'm going to go down 3 over 1. And again, I'm going to do it a couple times because that just makes your line more accurate. You'll learn next year that 2 points technically make a straight line, but when we're using a ruler, they don't always end up being super accurate. The more points you can put, the more accurate it is. And because I'm struggling to get a straight line, I'm putting lots of points on it because that's just helping me to draw a straighter line. But you guys have a ruler, so if you put at least 3 points on there, you'll get a pretty straight line. Let's graph our next one. Y equals a half x minus 3. So I'm going to start at a negative 3 on the y. And then we're going to go up 1 over 2. And I will also tell you guys, when you're graphing these, they will always intersect at a really nice point. It'll always intersect at a grid corner. If not, you didn't graph correctly. or your line was not straight. So hopefully you are seeing that these two lines do intersect, and they intersect at this point here. So because they intersect, this means that there is one solution, and it looks like that ordered pair is 1, 2, 3, 4, -1. Again, that looks like where it intersected on the graph. The great thing about checking is you can find out if you graphed wrong or not. Because if we check this ordered pair, it's going to work in both of those equations. So let's just double check to make sure that ordered pair is correct. Because maybe I went up and I was supposed to go down at some point with my slope. Or I ran the wrong direction. Your checking will catch that for you. So here's my first equation. And I'm going to check my ordered pair. Remember, x is the first value, y is the second one. So y is -1. The -3 was in the equation, times 4 plus 11. So let's check. -3 times 4 is -12, plus 11 is -1. First adult at home gave us the go-ahead to do what we wanted. Let's check our second one. Fingers crossed it works in this other one. So y equals 1/2 x minus 3. Again, plugging in that same ordered pair. My y is -1. My x is 4. And checking. 1/2 times 4 is 2. Minus 3 is -1. Awesome. We got two true statements, so works in both equations. So this is for sure our correct solution. If you guys have questions, help each other out with it. Otherwise, let's move on to our last example. In our last example here, I'm actually going to have you guys try this one on your own. So if you guys can go ahead and try and graph this one. If it has only one solution, make sure you list that solution. And it's your choice if you want to check it or not. I'll be honest, I'm not going to show the work for checking for this one, but if you wanted to do that, that would be perfect. So if you guys can pause the video, when you guys are done with this one, go ahead and press play, and let's see if we come up with the same answer. Alright, when you're all done, here's what your graph should look like. For the blue one, that's your first one, starting out -2, going up 1 over 1. The second one I graphed in red, starting at a +3, and then going down 2 over 3. And again, I did that multiple times. And you'll notice again, I struggled to make my line straight and going through my points. Yours is going to look much nicer. But I knew where it was supposed to intersect at. Your intersection point was right here, and so because it intersected, you should have one solution, and that ordered pair is 3, 1. And again, if you were to check that in both equations, you would get two true statements. Every other ordered pair every other ordered pair you'd pick, it would not work in at least one of those equations. If you guys have questions, help each other out. Otherwise, you guys are going to have the rest of the time to work on the Solving Systems by Graphing Maze worksheet. I'm going to have the sub go ahead and pass out this worksheet to each of you guys. This is something I'm going to ask that you do on a paper copy again, so your answers are much more exact. And again, I'm going to ask that you're using a ruler with it or some kind of straight edge. Once everyone has their worksheet, I'm going to kind of just give you guys some extra instructions on it. There's no instructions printed on it, but I want to make sure that you guys understand what you're asked to do with it. So when you guys are ready, here's what your worksheet looks like. So the front side of it is basically this maze. Your goal is to get from the start to the finish. The back side is going to be for you to show your work, to show your graphing. I am going to expect that you are graphing as you're going. Okay, you don't need to, well, hang on, I'll explain some directions with it. You're probably not going to use all of these graphs. There's extras in there in case you make a mistake. So here's what you're going to do. You're going to start in this box here. You're going to graph this first one, and your solution is either going to be 1, -2, or it looks like -2, 1. My toolbar is a little bit in the way here. So once you graph, find your solution. That's going to lead you to the next box. So let's say you graph this first one. Here's your solution. So you're going to draw an arrow leading yourself to that next box. Then you graph this one. And now you're going to find out that one of your answers is 4, 1, 1, 3, or 3, 1. Whichever answer it ends up being, that's going to lead you to the next box. So you're going to keep working your way through the maze until your ultimate goal is to get to the finish here. If you graph and you don't get one of the ordered pairs that like leaves the box kind of thing, then you made a mistake, okay? Because it works for every single one of them. So again, if we were now in this box, your answers could be -2, -2, 2, 2, 1, 0, 0, 1, 2, 5. It could be any of those. And again, whatever answer it is will lead you to the next box. And you're showing your graphs on this side here. If you guys have any questions, send me a Schoology message or Remind 101 message. I will be available to check my phone and Schoology a couple times throughout the day here to kind of help you guys out with it. Otherwise, this is due tomorrow. Again, I do want you guys to do this on a paper copy, and you can turn it into the basket on that second shelf out there when you guys are all done. Otherwise, I will see you guys tomorrow.